Right, this is section 10.1, part 2. Alright, so in the first part of our series on 10.1, we talked about what a hypothesis test is, and now we're going to look at what are the null and alternative hypotheses and how can we identify them in our problem. Alright, so the null hypothesis, and we use the symbol H with a subscript 0. This is sometimes called H naught, not N-O-T, but N-A-U-G-H-T. But H naught, or the null hypothesis, H sub 0, is our statement of no change, no effect, or to be true, or suspect to be true, and we're going to be looking know about the null hypothesis is that it always uses the equal sign. Always, always, always. So I'll write some examples of the null hypothesis here in just a moment. But our null hypothesis will always use the equal sign. And finally, our null hypothesis is assumed to be true until we have proof that it's not. So it's kind of like innocent until proven guilty. We assume the null hypothesis is true, but then once we have evidence, we can say that we no longer believe the null hypothesis. All right, some ways that we'll see the null hypothesis written. So we always want to identify it. We usually put HO and then a colon. We always need to use a parameter. So I'll see this sometimes, and I'm going to do it in red because it's wrong. I will see H naught equals 0.5. No, 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 no. That is not proper notation. What is supposed to be equal to 0.5? I don't have a parameter. The null hypothesis is not equal to a value. The null hypothesis, that's just a label. That's just saying that here's our statement, colon. Now, what I need is the parameter, which could be mean. So I could have the mean is equal to 12. I would need context, but just the mean could be anything. I may have a null hypothesis that says my parameter, or excuse me, my proportion, my population proportion is equal to something. Now, remember, proportions follow the same rules as probability. Has to be something between 0 and 1. So maybe 0.5. That's common. And then we won't be doing this for our class, but you may see in 10.1 anyway that the standard deviation could be equal to something. So there we go. Now standard deviation would have to be a positive number, but otherwise it doesn't really have any limitations. So those are some possible ways of writing out the null hypothesis. We always use that equal sign. Always, always, always. And this is our statement that we assume to be true until we gather that evidence to the contrary. All right, so our alternative hypothesis, which actually has multiple possible symbols, H1, H with a capital A and H with a lowercase a. These, of course, are all still subscripts. Our textbook seems to primarily be using the H sub 1. But if you see me or you find another video and you see the HA with a capital or lowercase a, it's still the alternative hypothesis. And there's only ever one alternative hypothesis. So there is no H sub 2. That's not going to exist. Not within one hypothesis test. So that's our alternative hypothesis. And what is that? Well, it's our statement that we're trying to support with evidence. We're looking for our sample data to give us the evidence we need in order to support this statement. So for a prosecutor, if we go back to that idea of being in court, we said the null hypothesis was, innocent until proven guilty. Well, the alternative hypothesis is that they're guilty. And so the prosecutor is looking for evidence to support that statement, that the person they are prosecuting is guilty of whatever crime they're being convicted of. And then we never include equality with our alternative hypothesis. So we're never going to use equal, less than or equal, greater than or equal. So we will not see those in our alternative hypotheses. Now, as far as what will our alternative hypothesis look like, well, again, I'll try and use the H1. I'm used to using the H with a lowercase a, so if I do that at some point, forgive me. I'll try to be careful, though. Again, we don't want to say, I'll do it in red again, that H1 is less than 0.5. That is not okay. That is not, our alternative hypothesis is not going to be compared to a value. It is a label, and that is labeling what our parameter is, what we're expecting our parameter to be, that it's not equal to whatever the number is. So we're going to have maybe mu is not equal to 10. I think I said 12 in the other example, but in fact, let's change it. Because if these were matching up with what we had, then it would be the same number. So mu is not equal to 12. I could have an alternative hypothesis that says that our proportion is more than half. So that would maybe be the majority. And then again, we won't see the standard deviation. We won't actually be doing any hypothesis tests for standard deviation, but we could write the null and alternative hypothesis. And that would be that the standard deviation, let's see, I haven't used less than yet, so is less than 3.5. So, for some reason we feel like the sample that we have comes from a population that is less spread out, has less variability than the total population. All right, so I've drawn 3 normal curves here so that we can kind of see what's happening when we are looking for and what we're doing with our hypothesis testing. So we'll figure out these values in our next sections, but what's happening when we talk about a one-tail test versus a two-tail test? Well, let's start out with the same null hypothesis for each one. We're going to say that we believe that half the time a particular event happens. Maybe we're just looking at coins being flipped, and half the time we think that this coin should land on heads. Well, if we go with the example that they did at the very beginning of the interactive assignment, the guy says that your friend flips a coin and it lands on tails or heads, one of them, 5 times in a row. If we say, we think it should be 50% of the time, but it ends up being more than that, then what we're going to be looking for is evidence that is, greater than that 0.15. And so if we ended up with a sample and we got heads somewhere, even if it was super extreme, let's say it was just all tails, and we got some value down here, that's not going to give us the evidence we need to say that it lands on heads more than half the time if we're looking for things that are in this direction. Likewise, if I have the same idea, something should be happening half the time. I've got half the time I think something should be, a coin should land on heads half the time. But instead, I have a reason to believe that that's happening less often. Well, same idea. In order for me to have the evidence that I need evidence of it being significantly below 50%. If I end up with some value that's super high and, like 90% of the time it landed on heads, Well, that doesn't give me the evidence I need for this alternative hypothesis. Now, if I just think that this coin is not a fair coin, and I don't know what's happening, I don't know if it's too many heads or too few heads or whatever, then I still think, that coin should be landing on heads half the time. But for some reason, I don't believe it is. Now I can say, aha, well, anything that's extreme in either direction will now give me the evidence I'm looking for. So that's the difference between a one-tail test and a two-tail test. So let's practice just identifying the null and alternative hypotheses. So I'm just going to try and figure out what is the null hypothesis, what is the alternative. So suppose a professional basketball player historically makes 38% of his three-point field goals. His coach wants to know if there is significant evidence that the player's three-point field goal shooting has improved after months of rigorous off-season training. So the first thing we need to figure out is what parameter are we dealing with? And there are three that you might see in section 10.1, but there are only two that we're going to deal with in section 10.2 and 10.3 actually doing hypothesis testing for. So it's possible that we are dealing with a mean. It's possible we're dealing with a proportion, and it's possible that we're dealing with a standard deviation. In this case, one thing that's a big clue is that percent sign there. So this percentage and proportion go together, so I know that I'm going to have a p as my parameter for my null and alternative hypotheses. That will always be the parameter, never ever the statistic. So we will never use x bar, p hat, or s when we're writing out our null hypotheses. The next thing I need, of course, I always know that my null hypothesis will have equals. So there we go. Part of our problem has already been, we've got half of it. We need the numbers and the second symbol. Well, here's the good news. The number that we use for the null hypothesis will always be the same number that we use for the alternative. So we really just have two parts left. So if I can figure out the number, and there is only one number in this problem as it's stated right now. However, when you have an entire problem, you will probably be given both a parameter that's expected for the null hypothesis and sample data or a sample statistic. So you've got to make sure that you pay attention, and again, that reading comprehension comes in. Make sure that you're reading and identifying everything correctly. So now, if that number is 0.38, so is this one. And I just need to know what symbol should I use for my alternative hypothesis. Well, the coach is trying to figure out if his shooting has improved. So not has it changed. If it's gotten lower, then it's definitely not improved. So I do not have evidence of the basketball player being better. However, if I can get a higher percentage, a higher sample proportion, p hat, if it can be far enough away from this 0.38, far enough above 0.38, then I will have the evidence I need. So there's my null and alternative hypotheses. Let's take a look at another one. Here we've got, according to the National Sleep Foundation, children between the ages of 6 and 11 years should get 10 hours of sleep each night. A doctor wants to conduct a survey to see if 6 to 11-year-olds are sleeping less than the required amount of time each night. So again, our first question is, what parameter are we dealing with? So is this a mean, a proportion, or a standard deviation? And this one doesn't really have a word or a symbol that leads us to believe one way or the other without actually getting into the problem. So what I need to do is think, do I have a proportion, or am I talking about the spread of something? No, I'm talking about a value that I could find the average amount of sleep for a group of 6 to 11-year-olds. So I can find the mean for that. So that's going to be my symbol, my parameter. Of course, my null hypothesis will be equal. If we read through, what should it be equal? Well, they should get 10 hours of sleep. So that's going to tell me what my number should be. It should be 10. And the doctor wants to know if they are sleeping less. So if it's less than that required amount, then I'm going to use the less than symbol. All right, so now we've got another survey conducted by Pew Research to see if there is evidence to suggest that a majority of adult Americans without a high school diploma are worried about having enough saved for retirement. Now, there are no numbers, there are no symbols. This could really get difficult to figure out if we don't, again, read and look for those keywords. So the keyword we have here that helps us is majority. Is there evidence to suggest that a majority of adult Americans, anytime we have that majority, you should think majority means more than half. If I'm thinking about half, I'm thinking about proportions. And of course, more than half, so that means that my null hypothesis will be that P equals 0.5. Majority means more than half. So that's going to stay 0.5, but I'm going to be greater than. All right, here's another one. This one's got a lot of wordy stuff at the beginning, but we need that context, and we've got to be able to read through and identify what is just context that we're being given and what is information that I'm using to identify the null and alternative hypotheses. So to start off with, we're told that the Graduate Management Admissions Test, the GMAT, is a test required for admissions into many Masters of Business Administration programs. So that's just MBA programs. The administrators of the test claim that the mean total score is 529. An MBA admissions counselor wants to see if there's evidence that the mean score of admitted students is different from this number. So, null and alternative. Now, we do have a clue here. We have the word mean score. So the mean, that immediately tells us I'm using mu. And then what should that score be? Well, the known mean for the entire test, according to the administrators, the people who write this test and collect the data for everyone who takes it, says that it's 529. Now, as far as our symbol, this is not one we've seen yet. We want to know if it is different from 529. So they're not looking, is it more? Do our students have a higher mean score? Or do our students have a lower mean score? We just want to know if it's different from that average or that mean. And so we will use not equal to. Here's the neat thing about the not equal to sign. It points to both tails. So that tells us that we're going to a two-tail test. We can get evidence in either direction, much lower or much higher, and we'll have evidence to support the alternative.